Welcome. In this video, we have a beautiful question there. Let's go. An organic compound weighing 6.5 mg gave on combustion 20.47 mg CO2 and 8.36 mg milligram of water at 100 degrees centigrade and 760 millimeter of mercury. 0.284 grams of the compound occupied a volume of 100 milliliters. Calculate the percentage composition and the empirical and molecular formula. Let's go. Now, of course, the first thing for we to do in this, this is probably one of the most difficult questions you will see under empirical formula. Probably. We have to get the mass of carbon and hydrogen, of course, and then from there, we'll get the molecular mass, and then the question is over. Now, let's get to work. From here, you want to get the mass of C as normal. This is the part 3 of the video. Watch my part 1 and part 2 for you to actually understand what I'm saying here. So, as usual, we have 1 mole of carbon in CO2 times the mass given, right? Times 20.47. So, this is 12. All over the total mass, molar mass of here is 44 times 220.47. Hydrogen, we have 2 hydrogen in water, H2O, right? Times 8.36. Now, if you punch it in your calculator, this will give you 5.58 mg of C, while this should give you 0.929 mg of H. Now, let's continue. From this place, of course, you want to get the mass of oxygen, right? So, for you to get the mass of oxygen, you need to add these two together, subtract it from the mass already given there, which is 0.28, which is 6.5. So, which is 6.5. The organic compound weighs 6.5. So, 6.5 minus, you plug this together, 5.58 plus 0.929. And what you get is 0 actually. So, if you got 0, it means that we're only solving carbon and hydrogen. Right? Because if you plus these two numbers together, what you will get is 6.5. Now, this is for hydrogen, this is for carbon. And then, of course, before we continue, remember the first question is calculate the percentage composition. Calculate the percentage composition. Now, the percentage composition is, what is the percentage of carbon in the mass already given? So it's just so easy. We have the organic compound weighs this. So the first question, which is a percentage composition, they want you to know what is the percentage of this inside that organic compound. So the percentage composition of C is equal to 5.58 all over 6.5. Well, of course, whenever you hear percentage, you have to multiply by 100. And so this will give you 85.8%. Now, the percentage composition of hydrogen is 0.929 all over 6.5 times 100. That will give you an answer of 14.2. So you have 14.2 here. Now, that is the answer to the solution of 1, right? Now, the second one is calculate the empirical formula and molecular formula. So the number 2i, let me solve the empirical formula first. After I solve the empirical formula, I'm going to proceed to solve the molecular formula. Now, because I want to clean here, want to clean this place. So you have hydrogen, carbon, and then of course we have gotten 85 and 14, right? So we have 85.8, 14.2, divide by 1, divide by 12. Of course, this should give you, no. This is for carbon and this is for hydrogen. So if you divide here by 12, here by 1, so this will give you 7.15, and then this place will give you 14.2, right? So you can see that we have to divide by the one that have the smallest mole ratio, and that is divide by 7.15, divide by 7.15. So this should give you 1, and this place should give you 2. And so the empirical formula is CH2, and that is the empirical formula. Now let's proceed to calculate the molecular formula. And of course, from the molecular formula, let me clean this. Alright, my duster, I can't seem to find it. Now we want to calculate the molecular formula. And remember, molecular formula from the part 1 of the video is equals to the empirical formula times N, right? And then we said that molecular weight is equals to the empirical weight times N, right? Now we already know the empirical formula, right? But we don't know N. And in the question, we were not given the molecular weight, right? We were not given the molecular weight, but then we can find it. Now, don't forget that in the question that you were given, I hope you copied the question. Don't forget that in the question that you were given first, the temperature was in 100 degrees centigrade. So plus 273, that will give you 373 Kelvin. You have to convert it. The next thing is the pressure is 760 millimeter of mercury, which is equivalent to also 1 atm. Now, before we continue, we want to use this formula using the ideal gas formula, which is PV is equals to nRT. Why? We want to get the number of moles so that we can calculate the molecular weight, which is not given. And so your number of moles is PV all over RT. Now, listen carefully. If you want to know secret to universal gas constant, is on my channel. For you to know the R to use, when to use 8.314 and when to use 0.082 is on my channel. Endeavor to watch it. Now, the R we're going to use is equal to 0.0821 and atm liter per mole Kelvin. Now, this is the value of R we're going to use. It means that your pressure must be in atm, your volume must be in liters, and of course temperature and your number of moles should be in moles, and your temperature should be in Kelvin. So 760 millimeter of mercury is equivalent to 1 atm. And so, and at the question also, we were given that the volume was 100 milliliter. We have to convert it to liters, because for you to use this R, your volume must be in liters. So we have to convert it to liters. So that means that we have to divide that 100, you have to divide it by 1000. So dividing it by 1000, that will give you 0.1 liters, right? Now, all we need to do right now is just insert these things and start solving. So we have everything. So the next thing is for you to get the number of moles. So the pressure is 1 atm times 0.1 all over 0.0821 times your temperature, which is 373, and that will give you your moles is now 0.0033 moles. Now you have the moles. And remember that moles is mass all over molar mass. Moles is mass all over molar mass. Like I said, this question is kind of fun, and if you understand it, you enjoy it. So remember that this is mass all over molar mass. Now we have the moles, which is 0.0033, and the mass has already been given in the question, and the mass in the question I wrote was 0.284. Now we can calculate the molar mass. So all you need to do is cross multiply. So the molar mass is 0.284 all over 0.033, and that should give you an answer of 86.06 gram per mole. Now, if you have successfully calculated your molar mass, all you need to do right now is insert it into this formula that you are seeing here, and then your answer flow naturally. Now, insert it here. You already know that the molecular weight is empirical formula times n. Now, for you to now calculate the weight of the empirical formula, remember we calculated the empirical formula for the equation to be CH2 all over n. Now, this is 12 plus 2, which will give you 14. So you have 14 all in bracket n is equals to your molecular formula, right? Molecular formula. And your molecular formula is 86.06, which is equals to 14n. Therefore, your n is 86.06 divided by 14. And 86.06 divided by 14 should give you 6. Are you saying it? So all you need to do right now is just put it here. Your molecular formula, which is your empirical formula, times n, and your empirical formula is CH2, and your n is 6. Multiplying out, you'll be left with C6H12. That is your molecular formula, and that is the answer, C6H12. That is it for this video.